A mathematical expression or a graphical representation which relates the adsorbate on the adsorbent at equilibrium pressure and at constant temperature is known as adsorption isotherm. There are two types of adsorption isotherm: Freundlich adsorption isotherm and Langmuir adsorption isotherm. Let us write down that. Types of adsorption isotherm. First one is known as Freundlich adsorption isotherm and second one is known as Langmuir. Freundlich adsorption isotherm deals with the amount of gas which is adsorbed on the solid surface, whereas Langmuir adsorption isotherm deals with the adsorption of liquid on the solid surface. So now let us consider about the Freundlich adsorption isotherm. So we will be discussing basically on Freundlich adsorption isotherm. Freundlich adsorption isotherm is given by the formula x by m is equal to k into p to the power 1 by n. Where x by m is nothing but amount of adsorbate per unit mass of adsorbent, and P stands for equilibrium pressure and K and N are nothing but the constants. X by m represents amount of gas adsorbed. P represents pressure. K and N are the constants. Now, when we plot a graph of x by m versus equilibrium pressure, we get a curve. So, let us understand about the graph. So, x by m versus equilibrium pressure. The graph is like this. When we observe this graph, as the pressure increases initially, adsorption also increases, and it can be represented as x by m is equal to Kp. Then with increase in pressure, adsorption also increases, and it can be given as x by m is equal to Kp to the power 1 by n. And when we look at this part of the curve, it is parallel to the x-axis. That means that at high pressure, the adsorption has been saturated, and hence the curve is parallel to x-axis, and it can be given as x by m is equal to k into p to the power 0. And then when we draw a perpendicular, and that perpendicular, when it meets the x-axis, this particular point is known as saturation pressure, which is represented as Ps. From the graph, we can conclude that x by m is directly proportional to equilibrium pressure at low pressure. That is, x by m is directly proportional to pressure, and that is only at low pressure, whereas x by m is equal to k at high pressure. X by m is equal to k at high pressure. In this, we are supposed to remember the expression which is given by Freundlich adsorption isotherm, because it is important from the point of examination. Now let us discuss about the factors which affect the adsorption. We have various factors which affect the rate of adsorption. Just mainly we'll focus on the important ones. First one, nature of the adsorbate. Second one, nature of the adsorbent. Third one, the surface area. Fourth one, temperature. Fifth one, pressure. So how these variables can be affected, let us learn about that. The first factors is factors affecting adsorption, particularly gas on solid, the first one is nature of adsorbent. Second one, nature of adsorbate. Here, one thing we should notice that easily liquefiable gases are adsorbed easily. For example, sulfur dioxide, NH3, carbon monoxide, etc. rather than the gases which do not liquefy easily, for example, H2, N2, O2 and so on. So, the conclusion is easily liquefiable gases are adsorbed easily. Easily liquefiable gases are SO2, NH3, HCl, CO2, etc. Whereas H2, O2, N2, all these things are non-liquefiable gases. I cannot mention it as non-liquefiable gases, not easily liquefiable gases. Then moving on to the third factor, the surface area. As usual, we know that greater the surface area, greater is the adsorption. In particular, the surface area of adsorbent. Then the fourth one, temperature. With increase in temperature, chemisorption increases, and with increase in temperature, physisorption decreases. So, the fourth factor is temperature. And the last factor is pressure. With increase in pressure, adsorption of gases on the solid increases. When we come to the temperature, with increase in temperature, the adsorption of gases decreases. So, these are the different factors which affect the rate of adsorption of gases on solid.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದೀವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.